Alright, so today I want to explain how to take absolute control of functions in Godot. So functions, they look like this. You have your function name, you have your code in the function name that will do whatever you tell it to. Now, the callable is a variable type, and this variable type can be set to be any other function. So if you think about how an integer can be the number 8, the callable can be set to be another function. And this is the documentation. I recommend reading documentation. It's good for you. It's good for your soul. So rather than explain what a callable is, I figured I would just show you. I'm just going to very quickly set up a new script. I'm going to set up the ready function. We're going to add a variable. We'll just call it test callable. Set it to be a callable. And we're going to make a variable called set callable, where we will set the callable to be a function. So let's just call it the do function. And then if we make the do function, and in here I'm just going to print 5. What this will do, if I run set callable at runtime, this will set the test callable to be basically equal to this. So whatever this function does, this will do. It won't execute it, it will just set it to perform equal logic if called. So what we then have to do is just write test callable.call, and that will call the function. That is the same as doing do function. So we're gonna run this. And that prints 5 twice. We get rid of do function. Prints 5. So that is the basics of how to use a callable. Why is this useful? It's useful if you want to change any input values before executing a function. It's also useful if you want to execute code immediately before or after executing a function. Rather than explain it in a complicated way, I'm just going to show you something that I have made using callables. So this is a project I'm working on. I've worked on quite a lot. My strategy game project. It's running right now. This is what it looks like. It's just got some UI stuff going on. If we look at the remote, we can see there's a bunch of different nodes, all my different systems. And the important part that I want to focus on here, this is my game clock script. We've got all these systems, and we have one script that basically calls on each of these systems for them to do all of their logic. So I have, all of the population growth logic happens, and then all of the movement growth happens, and then there's migration, and then there's like information networks, and there's like economy, how much gold do they make, all of that stuff. And I have all of these callables appended into arrays, whether that's the day tick array or the month tick array. I don't have a year tick array. Maybe I'll make one day. But you can see here in the setup, the order in which they're appended, and then they are called in here. So on day tick, it goes through the array and it calls all of those ticks, one by one, executing all of their code in order. Now, an issue I have is that this is a strategy game, and I can basically scale this up infinitely to have an infinite number of provinces, infinite number of tiles, infinite number of population. The limiting factor is the speed at which it runs. And so it's really useful for me to know which part of the code is the slowest, which part is using up the most resources and taking the longest to process. Godot has a way of monitoring this. I'm going to turn it on. I made this button to turn it on. If you go into the debugger, pull this up, and I think it's at the bottom. Yep. So you can see these are all of my ticks. I actually don't need to turn them on. We can just see here which of these ticks is taking up the most value. If I turn the game speed up, it'll start ticking month by month. These are updated every time they every time they tick. So the way that I'm adding these ticks to the debugger is a method that I can only describe as a little bit heinous. So if I scroll down in my live tree, and we go to main, and we go, I mean, all the way through here, we can see I have this debug thing here, and here it has something called process monitoring. I'm gonna pull this up. This is the script I used to activate the tick monitoring on all of my systems. So you can get the tick time of something using this time.getTicks usec. It gives you a value. And then what's happening here is we're calling the callable. And then we are getting the tick after the callable. And then we just subtract the 2. And that's sent back up the pipeline to do other stuff. It's happening here. This is getting added to the debugger. There's code that does that. The fun part that I really like is this. So this is what's called when I hit my my button earlier, my button up here, the top left. When I hit that button, this is the thing that gets called. And what it does is it gets the array of callables in the game clock that I showed you earlier. It goes through all of the ticks, right? You can see here it's going through each of them. It iterates through each tick. It gets that callable, and then it makes a new callable that is the monitoring callable that puts this number in here. And it binds that tick callable as an argument to this time checking function. So we've got this function, which basically every time this is called, we have a version of this here. Every time it's called, it's gonna already have this guy, each tick as an argument. And then we replace in that array again. So this is the array we're iterating through right here. It's right here. This is the array. We replace that old callable with our new callable. And our new callable is, it has the old callable inside of it. We've made a new one with that old callable inside of it that is going to call right here because it gets sent down this pipeline of functions to here that it gets called. But also, on top of that, it's allowing us to get the amount of time that it took to call. So you can basically just, like, hijack callables and do what you want with them. The fun part in all of this, if we think about our project architecture for a second, is that the node that we're referencing with the callables in doesn't even know that anything is happening to them. So we could delete this and it would stop the monitoring code from working, but the callables that were being modified are none the wiser. They will just continue functioning as they were, blissfully unaware that anything could have happened to them. So I hope that's demonstrated one of the ways in which callables can be exploitable for your own decision making. You can build things in interesting ways. You could probably make some really fancy looking code with it. And you could almost certainly weaponize it to make extremely confusing code. So if you know anything about Godot, you know that signals are the bread and butter of connecting nodes. It's almost always the recommendation that you use signals to communicate between nodes. It helps reduce the amount of direct referencing you do because that's all kind of managed by the engine. I showed you earlier that I had control of the order of operations of my signals in my strategy game. Right here, where I'm appending all of these, and then later they go, you know, through this array and get called one by one. These used to be signals. I didn't know what order they would be executed in, and I just replaced them with callables because I didn't really know, and I didn't know how to sort of look that up, and I didn't know if it was some engine magic that was happening without me knowing. So if you think about the way that signals work, you're always going to have a signaling node, right? This is the signaling node, okay? And that is going to have, its signal is going to have some other nodes that are connected to it, right? And they're all going to receive the signal, and they're all going to execute their own functions, okay? This is functionally, in terms of logical execution, the same as having an array of callables in here that are called one by one. Except it's engine code, and you don't really know what it might be doing. But signals, probably the more advisable method, just because it comes with the safety net of a lot of internal optimization and error checking and other stuff like that. But, you know, all of these callables are being executed by when the signal activates. Order of operations wise, it is very similar in concept to just have this node having an array of callables. I could have just read up on signals, but I chose not to do that because I kind of just wanted to see what I could make with callables. It's kind of fun. It's kind of fun to make stuff with weird new tools, you know? You always want to make something interesting, usually, without going too power mad. Anyway, let's read up on signals, shall we? So this is the link to the GitHub of the Godot engine. You can go here and you can read this code yourself. This is the page. I'm actually in Godot.core.object, but if I go here, this is like the main Godot page. If you go search up Godot GitHub, it's like the first entry. You can just like click on stuff. And it's got scripts in. You can read them, you know. Just go read anything. Looking through the engine code, in the object C++ file, there is a line of code right here on 1293. You don't have context yet. I'm about to explain a little bit of the context to you. But this line here is calling callable.call with a bunch of arguments. I haven't checked exactly where they're coming from. I haven't done too much reading, but it basically seems to be that a callable is being called right here. If we scroll up, this is happening inside a for loop that is iterating through an array called slot count that appears to be getting a callable, and this is the callable here that's being called later. You can see callable.callp. There's a lot of code. A lot of it appears to be error checking. I don't have a full understanding. I have a very limited understanding, but we can see here that we're just iterating through an array of callables and calling them. And this, if we scroll up, is happening in the object.emit signal function. So it kind of seems like what's happening on the internal side is just Godot iterating through an array of callables and calling them when you call emit signal on a custom signal. It might be the same for the built-in signals. I have no idea. I haven't checked. In conclusion, callables are cool. They're useful in specific circumstances. Maybe you could go power mad. You could probably go power mad if you really want to. If you want to like build something super crazy where nodes are modifying each other's functions, sort of super systemic, complicated, modular code thing, I could probably build something. I'm not going to spend my time, but it would become very confusing very quickly, but it would be kind of funny. Anyway, I hope you learned something. Have a nice day.